Module 14.6. In this lecture video, I'm going to demonstrate how to solve what we so-called the rational equations. So the steps are as follows. The first thing we're going to do is find the least common denominator of all the fractions. And then every one of these problems, we will need to list any restrictions. Okay, if any one of these values or any one of these restrictions appear as a solution, then it must be rejected. Then step number 3 is where we're going to clear the fractions. Multiply every term by the least common denominator, and then we're going to solve accordingly. So our equations by then can be a linear equation or it can be a quadratic equation. All right, so let's take a look. All right, the first thing, step 1 of the 2, state any restrictions if I have any. So just like what we did in module 14.1, we set each denominator not equal to 0, so we know what x cannot be. So both of these are linear equations, so move the -3 and the +7 to the other side. All right, let's see, one of my x cannot be +3, the other x cannot be -7. So here are my two restrictions for step 1 out of 2. All right, now let's solve. So before we solve, let's find the least common denominator. So I basically have 3 denominator. The equal to 1 means 1 over 1. So since that's a 1, I'm just going to look at the x minus 3, x plus 7. So both denominator cannot be factored. So other than 1, so we will put them in the parenthesis. All right, so I gotta count each one time. So my LCD got to be x plus 7 and x minus 3. So we're gonna use the same technique as we done before. All right, let's take a look at this equation up here. Multiply every term by the least common denominator. So I'm gonna write it down this way, just this time, okay? So next time we can just do it just by looking at them. So this x minus 3, there's nothing to factor out other than 1, so I'm going to put them in the parenthesis, plus 2 times, the second denominator is x plus 7, nothing to factor out other than 1, so put them in the parenthesis, indicating I factor out a 1 is equal to 1. So now we will multiply every term by the LCD. Okay, so when every term by LCD, that's LCD over 1. So basically the top x minus 3 and the bottom one will cancel out. So that just leave me with x plus 7 times -3. So this is going to happen every time for every term. So basically we can use the same trick as we done before. What does the LCD has that my second denominator do not have? My second denominator do not have x minus 3. So we take that x minus 3 times the numerator. So what happened to the x plus 7? The x plus 7 this time should get canceled out, because I'm multiplied by the LCD for every term. Okay, so that's basically the idea. Equals, all right, the denominator under the 1 is a 1, so if every term, so what does my third denominator, what does my LCD has that my third denominator do not have? My third denominator do not have both of these. So we take both of those times my numerator 1. So that would just still be x plus 7 times x minus 3. So that's basically saying when every term times by the LCD, x plus 7 times x minus 3. Okay, nothing is going to cancel out in this case. Nothing will be canceled out top and bottom, so that would just be 1 times plus 7 x minus 3. So that would look just like this. All right, so basically very similar technique as before. It just before when we do adding and subtracting, I still have to write my LCD down. But now since I'm clearing the fraction, then my denominator should always cancel out, and we will see what's left, okay, on the numerator. All right, let's solve this equation accordingly now. I got 2 terms on the left, so I will need to do a quick distribution. So that should give me negative 3x minus 21, positive 2x, negative 6 equals. The right-hand side of the equal sign is only 1 term. So when I see 2 parentheses being multiplied, I think about my FOIL methods. X times x, x squared. Positive 3 times negative, positive 7 times negative 3 is negative 21. That's the last thing I do in FOIL methods. So let's see, my middle term, inner and outer combined. That's negative 3 plus 7, which is positive 4x. All right, so just by looking at this equation, I actually got myself a quadratic equation. So we will solve this quadratic equation by factoring. So let me clean this up on the left side here before I move any terms. Negative 3x plus 2x is negative x. Negative 21 minus 6 is negative 27 equals x squared plus 4x minus 21. All right, so when we're solving quadratic equation, we have to move all the terms to the same side, like the other side equal to 0. So I'm going to move these 2 terms on the left to the right so I can keep my leading term, x squared, positive. So when the negative x come over, it becomes positive x. Then that will combine with my positive 4x, so I should get positive 5x. When the negative 27 come over, it becomes positive 27. Negative 21 plus 27, it should be positive 6. All right, so now let's factor for my trinomial here, 2 parentheses, x and x, 2 and 3. My sign got to be both positive. All right, so once I factor, we will set each factor equal to 0. All right, so one of my x is equal to negative 2. The other one is equal to negative 3. All right, so now let's take a look at my solution and check against my restriction. All right, 3 and negative 7, my 2 solution is not those, so these 2 got to be my answers for my equation. All right, let's try again, okay? All right, let's write down this restrictions first. So this time I got 3 separate denominators, so let's write down, let's find the restrictions. First denominator, x minus 2 cannot equal to 0, therefore x cannot be positive 2 by moving the negative 2 over. The second one, x squared minus x minus 2 cannot equal to 0, so this is a quadratic equation I'm pretty much solving. So let's see what I came up with. X and x, 1 and 2. Last term is negative, so there got to be 2 different signs, positive and negative. So you got to be negative 2 and the positive 1, right? Negative 2 on the outer, positive 1 in the inner. So set each factor not equal to 0. So one of my x cannot be positive 1, the other one cannot be negative 2. Excuse me, positive 2. Negative 2 move over becomes positive 2. So still I only got 2 different kind of restriction, right? Cannot be 1, cannot be negative 1, sorry. Positive 1 move over become negative 1. Cannot be negative 1, cannot be positive 2. My third denominator set it not equal to 0, So the other x cannot equal to -1. All right, so my restrictions are can't be -1 and cannot be +2. All right, since I already factored my denominator here in the middle, that would be a lot easier to find LCD here. All right, let's find LCD before we multiply every term by that. So x minus 2, there's nothing to factor out other than 1. So I'm going to put it in the parenthesis. The x squared minus x minus 2, I just factored it. I can write them as x minus 2 and x plus 1. All right, the third denominator is x plus 1. There's nothing to factor out other than 1. So that would just be x plus 1. So my LCD would just be minus 2 and plus 1. So basically, I'm going to take a look at my equation, all right, and noticing, all right, this first denominator, I basically already factored down here. The middle denominator, I already factored as x minus 2, x plus 1. And my third denominator is simply just x plus 1 in the parenthesis. So let's take my LCD, multiply every term. So with my LCD times the first term, okay, the x minus 2 should cancel out. Or we can say, what does my LCD has that the first denominator do not have? The first denominator do not have x plus 1. So we take that x plus 1 times the numerator, which is x up here. All right, minus 3x times my second denominator. As compared to the LCD, it does not missing anything because when my LCD times the second term, okay, everything should, the denominator and LCD should all cancel out. So that would just leave me with negative 3x equal 4 times. All right, try it again. What does LCD has that my third denominator do not have? It does not have x minus 2. So we take that times the numerator. So what happened to the x plus 1? The x plus 1 should get what? Canceled out top and bottom. All right, so rather than do this step every single time, times every term by LCD, we can do it just by simply looking at them and notice that the plus 1 can cancel out. That would just be 4 times x minus 2. All right, so back in module 9, I demonstrated how to clear the fraction constantly because we're using the same concept to solve the rational equation. All right, let's multiply this thing out and let's see what type of equation I got. So let's do a distribution here for my first and the third term. So that gives me x squared positive x, still got negative 3x here, equal to 4x minus 8. All right, so because the x squared, that tells me that I got myself a quadratic equation. All right, so let's clean this up a little bit. This is x squared minus 2x on the left side equal to 4x minus 8. Let's move all my term to the left side so I can still keep my leading term x squared positive. So x squared still x squared. Positive 4x move over, become negative. Combine with negative 2x is negative 6x. Negative 8 come over to the left side. Has nobody combined with. That would just be positive 8. All right, so for my trinomial, we will factor just like we did in module 13. For 8, 2, and 4, both of them got to be negative. Set each factor equal to 0. My x is equal to 2. The other x is equal to 4. All right, so my answer are 2 and 4. But if you check against the restriction, remember the restriction says x cannot be positive 2. So that means this x equal to 2 cannot be my answer. Therefore, my only answer is going to be x equal to 4. All right. All right, so this one is similar to the very first one that we did. Let's do the restriction. X plus 2 cannot equal to 0, so x cannot be negative 2. The other denominator, x minus 4, cannot equal to 0, so x cannot be positive 4. Under the negative 2, the denominator is just 1. So it has no variable in it, so I don't have to set it not equal to 0. So here are my two restrictions. All right, just by looking at it, I believe my LCD got to be plus 2 and minus 4, since none of the factor repeated between the two denominator. So count each one time. Plus 2 and minus 4. So when I take my LCD, multiply every term. With my LCD times the first term, right? The plus 2 will cancel out. So that's leave me with x minus 4 times negative 2x. Or you can say, what does the LCD has that my first denominator do not have? It does not have x minus 4. Take that times my numerator, minus 3 times. Well, my LCD times the second term, right? The minus 4 will cancel out top and bottom, so that leaves me with the x plus 2 times the numerator. All right. Or you can say, what does the LCD has that my second denominator do not have? Second denominator do not have x plus 2, so we take that times the numerator equals negative 2 times. Well, the third denominator is missing both of these, so that means nothing will cancel out with the 1 in the bottom when I take the LCD times the negative 2. So that would just be negative 2 times x plus 2, x minus 4. All right, so it seems like this problem does take a little bit of work. Let's take a look. All right, on the left side of the equal sign, my first two terms. Let's do a distribution. So that should be negative 2x squared plus 8x negative 3x minus 6 equals. All right, let's do this. This right side, all is one term, but there are three things going on here. Three multiplication going on. I'm going to do my two parentheses first. So when I do a FOIL method, I'm going to write it slightly up here. When I do my FOIL method here, that should be x squared. The last thing I do is positive 2 times negative 4, which is negative 8. My inner and outer combined give me my middle term for the trinomial, which is negative 2x. And these three terms is going to now get multiplied by negative 2. So when negative 2 do a distribution here, all right, I should get negative 2x squared plus 4x plus 16. So we write it all in one line, so we don't have to keep on rewrite. It's the same thing over and over. Now this is an interesting one because we do see a negative 2x squared on the left and the same negative 2x squared on the right. So those two automatically cancel each other out. So when the x squared canceled out, that means the only thing I got left with is x to the first power, which tell me that's going to be a linear equation. Okay, so we will just solve this like a regular linear equation. Let's clean this up a little bit. Ax minus 3x is 5x. Still got negative 6 there. On the right side, positive 4x and positive 16. So solving linear equation, let's move my x's to the same side. 4x is smaller than 5, so let's move this over, become minus 4x. So 5x minus 4x is 1x. At the same time, though, I can move my negative 6 over, become positive, which 16 plus 6 should give me 22. So my answer, x equal to 22, because when I check against my restrictions, it's not, I'm okay. This answer is not part of the restriction, so this is my answer. Alrighty. Let's try another one. Alright, so they all work the same way, okay? They all kind of work the same way. Alright, I got three different denominators here. There's only two of them are different, so I'm just going to set up x minus 7 not equal to 0, and the 3x plus 1 not equal to 0. So both are linear. So one of my x cannot be 7. Move the positive 1 over. That's 3x not equal to -1. Divide both sides by 3. The other x cannot equal to -1/3. So here are my two restrictions. All right, let me find the LCD up here, okay, real quick. So, all right, I got x minus 7, 3x plus 1, x minus 7. So the two x minus 7, there's nothing to factor out other than 1, so I'm going to put them in the parenthesis. All right, the 3x plus 1, there's nothing to factor out other than 1, so I will put that in the parenthesis to indicate I factor out a positive 1. So my LCD here, the x plus 7 repeated, so we will count that one time. The 3x plus 1 did not repeat, count that one time. So now imagine taking this LCD, multiply all three terms. So let's just do this quickly. So the first term, the LCD times the first term, the minus 7 will cancel out. Or you can say, what does the LCD has that the first denominator do not have? The first denominator do not have 3x plus 1. So we take that times the numerator, which is x plus 1. The x plus 1 is two terms representing one numerator. Put them in a parenthesis, minus 4 times. The second denominator is missing the x minus 7, so we take that times the numerator, -4, equal. The third denominator is missing the 3x plus 1, so we take the 3x plus 1 times the numerator, x plus 4. Again, two terms for one numerator, put them in the parenthesis. All right, so basically, LCD times the first term, the minus 7 cancels out. LCD times the second term, the 3x plus 1 will cancel out. So that leaves you with x minus 7 times -4. LCD times the third term, the minus 7 will cancel out. So that becomes 3x plus 1 times x plus 4. All right, let's multiply this thing out here. All right, so this is my first term, my second term here, and my third term. All right. So it looks like my first term, I gotta do a FOIL methods. So the first thing I do is x times 3x, which is 3x squared. The last thing I do is positive 1 times positive 1, which is positive 1. My middle term comes from inner and outer combined, so that will be 1x plus 3x, which is 4x. All right, my second term, let's do a distribution. So that should give me -4x plus 28 equal. All right, my third term, let's do another FOIL method. The first thing I do is x times 3x, which is 3x squared. The last thing I do is positive 4 times positive 1, which is positive 4. All right, my middle term is my inner and outer combined. So outer is 1x, inner is 12x. So that together will give me 13x. So this one just like the previous one. The 3x squared on the left and the 3x squared on the right side, the equal sign will cancel out. As a matter of fact, the 4x minus 4x will also cancel out on the left side. So on the left side, I should only have 29. 1 plus 28 equals. The right side is 13x plus 4. So since the 13x is my only variable term, I'm going to move my positive 4 over. So that should give me 13x equal to 25. Divide both sides by 13. My answer, 25 over 13, which is not part of my restriction. So therefore, my answer, 25 over 13, is legitimate. Alrighty, let's do another big one here. So let's try another big one right here. Let's do restrictions. Let me go ahead and factor the middle one too. 3x minus 2 cannot equal to 0, so that x cannot be 2/3, right? Move the negative 2 over, divide both sides by 3. The third one here, x minus 2 cannot be 0, so that x cannot be 2. 3x squared minus 8x plus 4 cannot equal to 0, so let's factor this trinomial. 3x and x, 4. I can use 2 and 2. So my outer is 6, my inner is 2. That will give me 8 in the middle. Since the last term, the last sign is positive, the two signs got to be the same. So in order to get negative 8, both of them got to be negative. So when I say each factor not equal to 0, these are the same factor as the other two denominator. So that x cannot be 2/3. And this one cannot be positive 2 again. All right, so I basically just have two different restrictions. X cannot be 2/3, x cannot be 2. So let's find the LCD. When it comes to finding LCD here, I basically got 3x minus 2, x minus 2, and my middle one turns out to be 3x. My middle denominator turns out to be just 3x minus 2 and x minus 2. All right, 3x minus 2 cannot be factored, so we write them in the parenthesis, indicating I've just factored out a 1. The x minus 2, nothing can be factored out other than 1, so put them in the parenthesis. So my LCD in this case is just going to be the 3x minus 2, because those two repeated, and the x minus 2 repeated, count that one time. So if it helps, sometimes I see students rewrite the middle denominator like that as a factor form. So it helps them to see how it's canceled. You can do it like that, or you can do it by the saying, what does the LCD have that the first denominator do not have? The first denominator does not have x minus 2, so we take that times the numerator. So that would just be 3x plus 5 times x minus 2 plus 7x plus 6 is two terms for one numerator, put it in the parenthesis. All right, so when the LCD times the second term, all the denominator and the LCD will all cancel out, so that would mean times by 1. Everything cancels out, that would just be 1. I'm going to put that 1 right here in the front. Rewrite this. Put that in red. All right, equals. All right, third, LCD times the third term. What does the LCD has that the third denominator do not have? The third denominator do not have 3x minus 2. We take that times the numerator. All right, because the x minus 2 got canceled out. X minus 2. Alrighty, so now let's multiply this out, okay? All right, these two terms, let's do a quick FOIL method. The first thing I do for FOIL method, 3x times x, 3x squared. The last thing I do is positive 5 times negative 2, which is negative 10. All right, my outer is negative 6, my inner is 5x. So when that combined, it will give me negative 1x. All right, positive 1 do a distribution. That should be positive 7x and positive 6. Is that right? Make sure that's correct. Yep. Equals. All right, the right-hand side, let's do a quick FOIL method. First thing I do, x times 3x, 3x squared. Last thing I do, positive 3 times negative 2 is negative 6. My outer is negative 2, inner is 9x. 9x minus 2x, positive 7x. So here, once again, I see my I got a 3x squared on the left, 3x squared on the right, so they should cancel out right away. So once again, I got myself a linear equation to solve. All right, let's clean this up on the left side. Negative x plus 7x is 6x. Negative 10 combined with positive 6 is negative 4. The right side would just be 7x minus 6. All right, so 7x is bigger than 6x. Let's move this over, become minus 6x, so that will be 1x. Move the negative 6 to the other side, become positive 6. Negative 4 plus 6 is going to be positive 2. So my answer, x equal to 2. Now, this x equal to 2 is the same as one of my restrictions, so that tells me that x cannot equal to 2. So I basically have no solution in this problem, because my answer turns out to be the same as my restriction, so this problem have no solution. Now I kept this one at the very end. This one is different than all the other ones because this particular rational, this particular one only consists of 2 terms. All right, my restriction is the only one here. X plus 3 cannot equal to 0, so x cannot be negative 3. All right. So what do I do when I only got 2 terms? My rational equation only consists of 2 terms. There are a couple different there's actually one other technique that you kind of already know, which is treat them as treat this as like 2 fractions equal to each other. So that reminds you to do a cross product. Okay, I actually can use the cross product. Cross product is basically when you see 2 fractions equal to each other, you can think about solving proportions. So use that technique here, or you can find the LCD and multiply every term by the LCD. That's the same thing. So I'm going to take my 5 times negative 2x, which is giving me negative 10x, set it equal to x plus 3 times negative 2. So that will be negative 2 times x plus 3. So we can do it. So we can use the cross product technique for this particular example. So this is going to be negative 10x equal to negative 2 do a distribution. That's negative 2x minus 6. Negative 2x is bigger than negative 10x, so let's move this over. So that should give me 8x here. Move the negative 6 to the left. It's positive 6. Divide both sides by 8. 6 over 8. If I reduce that, that would be 3 over 4. So that's my answer. All right. So I waited a little bit to do this one, because this one we can quickly use cross product to write out our equation. So it turns out to be a linear equation here, so we just move our terms back and forth. All right, so in this lecture video, I quickly show you how to solve our rational equation by simply stating the restrictions and then find the LCD and take the LCD, multiply every term, okay, to clear out the denominators. And then we can solve it accordingly, whether it's going to be a quadratic or sometimes it can be a linear equation. All right, that will conclude this lecture video. Thank you for watching.